Okay, so we have a circular array, right? So let's take an example and try to understand it. So given a circular array, the next element of the last element is the first element of the array. I mean, if we have 1, 2, 1, so after this 1, we have again 1, right?
Yes, we have 1 and 2 towards, we can consider like 1 and 2 are towards its right.
Yeah, like we can see, we can assume it is like 1, 2, 1, then again 1, 2, 1, something like that, like a circular array. It just goes on and on. Okay, and so print the next greater element for every element. Like for this array, 2 will be greater than 1, and for 2, we don't have any greater element in this array, and for this one, the next greater will be 2, because we can see it is a circular array. So 1 to 1, 1 to 1. So for this one, we can have the element as 2. So like if I do it naively, then it will be like n square time, right? Like for every element, just check the. So we have the simple solution will be O of n into n. We just have for every element check the next element, and if we reach the end, we start again from beginning, and if we still don't find it, then return minus 1. If we don't find it, return minus 1. So we can implement this and then we can optimize it later. What do you guys say?
Yes.
I mean, I am thinking we can have one more approach to make it a bit more simple. So we can make this array 1 to 1 as 1 to 1 and 1 to 1, and only find the next element for 1 to 1. And if you don't find it in this array, then you return minus 1, because we don't need to do it again, right?
Yes.
Like what I mean is, like if we have 1 to 1, we can make a new array 1 to 1 and 1 to 1, and we just try to find the next greater element for this first 1 to 1.
First n number.
First n number. Yeah. So like make an array of 2n size, where like same, like we just concat the same array again and find next greater element for first n element. That would be my approach. You guys have any other better idea?
Yes, but like the time complexity for this will also be n square.
Yeah, it will be n square.
Implementation will be easier.
Exactly, yeah. It will have the same time and space complexity, but you don't have to worry about going the next, so it will be easier to implement.
Yes.
So time complexity will be O of n square, and space complexity will be O of n, right? Because we are just storing it again. So okay, let's implement it. So we have the answer, like next greater element array and modified array will be array plus array, like like nums. Let's make the nums as like nums plus nums. We'll print it so that you can see. Print modified array, and we can make a auxiliary function. Next, find next element, which will take this array and index and give you the next element in the array. So for I in range of index plus 1, like sorry, it's the number or index, index. So number, so it will find the next greater element for number at index int. Okay, let's make it more meaningful for the users. So number will be array and index, right? And so for index, for I in range of index plus 1 to length of array, if array I greater than number, return array I, right? Like I just find the next greater element. Is that clear?
Yes.
Any doubt you guys have about this function?
Just like in optimization, like we can only check the next n-1 numbers.
Yeah, so like we are doing for we can do it, but it won't improve any time complexity, right?
Yes. Okay.
So let's do it simply right now and return -1. Yeah, but I will note your point, so we can just consider the next n elements, right? Right? So yeah,
yes.
that can also be only the optimization, but that won't give us any beta time complexity. So for index in range of length of array, next getter element dot append, find next element, modified array, no, like next getter element, okay, and modified array and index. Okay, let's like make it maybe a bit simple. So we have the next greater element will be index, and we append this one and return element.
Yeah.
I think this should work.
Yeah, it is nums.
Nums, okay. Okay, looks all right. Let's submit it. So it will give, I guess, timeout error because it's on n square time, but it won't show you any like wrong message, like wrong output. So we have to do it in O of n time, right? Like we have this timeout because it's taking O n square time, and the length of array is 10 power 5. So you have to do it in O of n time. So, okay, how will you guys do it in O of n time?
Like we can use a stack
Mhm.
to keep. We can use a stack and traverse the array in reverse manner, so
Okay.
that the maximum element, the greatest element, is stored in the stack.
Okay, let's write it down. So you can describe it here. So you have this this one and
Okay. So like I'm first considering that the array is not circular, and then we can like modify our solution to make it work for a circular array.
okay,
right?
yeah, sounds good.
Okay. So our array is 1, 2, and 1. So at first we will travel from I equal to 2. So like I will write down the basic algorithm. Like so we have an empty stack. So our stack is empty, right? So what our output should be, like if we don't consider it to be circular array, like for the first element 1, its next greater element is 2.
Yes.
For the second element, it does not have any element greater than it, so it will be -1. And for the next element, it will be also -1, I think.
Yes.
-1. Okay. So when our array is when our stack is empty, if stack is empty, then we can say that element of ours has no maximum greater element to its right. So we make it -1. Else, if we check if the element at the top of the stack is greater than our current element. Suppose if stack.pick is greater than our element, so we will put it in our output array.
Okay.
So stack.pick, and if our element is less than this, like stack.pick is less than our array of I, then we shall pop elements from the stack until we get a greater element.
Yeah.
Like while stack.peak is less than equal to array of I, we shall pop them, and at last suppose if our stack is empty, then that element has no greater element in it.
Yes.
Or else we can say like stack.peak. Yes. So it can be understood by taking another example. Like suppose I have 4, 2, 7, 6, and 9. So at first our value of I is 4, and we should also make the stack here. Okay, so value of I is 4, and I is equal to 4. So okay, so if our stack is empty, so we put -1 as its greatest, next greatest element.
Yes.
So our answer will be like all these elements will be empty, right? And also we have to put that element in the stack.
Yes. So where are you putting it in the stack?
Yes. Okay. Stack dot push of array of I. So we have our stack as 9. Okay. So our next element is this 6. Index 3. The element is 6. So at first we will check if our stack is empty or not. So it is not empty. So we go by this condition. Else we check if our stack dot peak is greater than this element. So we check the top element of the stack. It is 9, and it is greater than our current element, which is 6. So we into the output array we put that. We put the top of the stack.
Yes.
So okay, and I think we don't have to. Okay. Now our stack becomes like 6 and 9. Okay. So next element is 7. So for 7, we will check the first condition, which is not correct. So we move to the next condition. Like here we have the top element as 6, and 6 is less than 7. So we 6 is less than 7. So we ignore this condition also, the second condition, and we run into our third if-else condition. So our peak element is 6, which is less than 7. So we pop elements from the stack until we found an element greater than it. So we pop 6. And we get our stack as 9. Okay, so as 9 is greater than 7, so we put it here, and 7 is put into the top of the stack.
Yes.
Okay, so next element is 2, and for 2, we will check the top of the stack, which is 7.
Yes.
So we can say 7 is this, and we put 2 into the top of the stack.
Okay.
And for 4, we pop the elements from the stack, and we get 7 as the output. So this will be my approach for a non-circular array.
Yes. Yeah, this should work. So maybe we can go to the other question and solve it, and then we can move to this question, right? Is one. This is the question, right? For the
Yes. Oh no.
No.
They are having 2 arrays actually.
Oh no, this is not the question. So you don't have the only one without circular? Anyway, it doesn't matter. So how would you extend it for a non-circular array?
Because in a non-circular array, suppose this array can be made as 1, 2, 1, and 1, 2 maybe. I don't think we have to repeat for the last element.
Yes, I think yes.
For this. Okay, so this is our method.
Yeah, maybe we can put these elements in the stack before, and from the I equal to n we can do the same thing. Will it work?
Or maybe we can use our modulus operation so that we put our elements. No. So our elements
I think
what happens if you put this 1, 2 in the stack, and you start with 1, 2 in the stack, and like 2 1 in the stack, and then you start from 1 to 1. Can it work?
Okay.
Chitresh, you had some point? Yeah, go ahead.
Yeah. I think this similar stack logic we can like start from index 0 also. Instead of from end, we can start the same logic from beginning, like from index 0.
Okay.
Then we can simply like 1 to 1, like our array 1 to 1, we can make it as 1 to 1, 1 to 1.
I can describe
we
it
did
in this
earlier.
page, and you can how would you
Yes.
solve it?
Yeah. Yeah. So 1 to 1.
Let's take the second example because that gives you also more clarity. Like let's take
Okay.
this 4 to 7 6 9 example.
Which one?
The one that
Okay.
Saurabh has taken, 4 to
Mhm.
9 6 4 to 7 6 9.
This
Yes.
one. This one.
Okay.
Yes.
Yeah. So I've just doubled it.
Mm-hmm.
Now I'll take one more stack.
Mm-hmm.
Yeah. So when we come to like at with the very first index,
Mm-hmm.
we will insert our number into the stack.
Mm-hmm.
Or I think it will be better like if we insert the index.
Okay.
Mhm.
So we will insert 0 into the stack.
Mm-hmm.
Then we will move to the next number, 2.
Mm-hmm. Mm-hmm.
Now we will compare this 2 with the number which is at this index, like at the top of the stack.
Mm-hmm.
So 2 is less than a of 0.
Mm-hmm.
So we will insert this also into the stack,
Okay.
like 0 1.
Mm-hmm. So like
We will come
also like create a stack with the numbers so that you understand. So it is the index stack, and
Yeah.
also like create a one more stack where we have the numbers, corresponding numbers.
Okay.
Mm-hmm.
Yes, that will be easier to visualize.
Yeah, exactly. Stack 2 will have
So here we have 4, then we have 2.
2. Okay.
Yeah.
Mm-hmm.
Now when we come to this index 7, we will compare it with the number at the top of the stack, that is 2.
2. Yeah.
Yes, so I'll create one more. Like this will be the answer.
Mm-hmm.
So since this 7 is greater than 2,
Mm-hmm.
so we will go to its index and we will like set the answer for 2 as 7.
Yeah. Okay.
Yeah, like we will do the same process like while our this stack 2 is not empty.
Mm-hmm.
So when we come to 7, 2 is less than 7, so we set this to 7.
Mm-hmm.
And then we remove this number from stack 2. Now we will consider 4. So 4 is again less than 7. So here also at index 0 our answer will be 7. Because
But-
7 is greater than
But don't you
both
think that
4
will give
and-
you O of n square time complexity?
No, I guess because we will be iterating through every index like at most 2 times. We will either be inserting into the stack or we will be removing from the stack. Like 4, first we inserted, then we delete, like index 0 we inserted and then deleted.
Okay.
Yeah. So now our stack, both the stacks will become empty.
Mm-hmm.
Like for 4 and 2 we have got the answer is 7.
Mm-hmm.
So in this now we will insert the index 2, that is for 7, and so in this stack we will have 7. Now we will move further. So index 3, so we will compare 6 with the stack top. So since this number is less, so we haven't find any answer, so we will again insert 0 1 2 3. So this number relates to 6. Now when we come to 9, so 9 is greater than these two numbers which are present in stack.
Okay.
Yeah, so we will do the same process for these 7 and 6. We will set the answer as 9.
Yes.
9, and then we will empty our stack. Like we will have 2 while loop iterations, and now 0, 1, 2, 3, 4. So 9 will be inserted into the stack.
Yes.
Same with 4, like 4 is less than 9, so we will insert it again. Index 5, number is 4. Same with 2, because like we are having a descending order.
Yeah.
So 4, 5, 6, 9, 4, 2.
Okay.
Now we have 7. So 7 is greater than 4 and 2. So we will be removing these two numbers and set the answer for them as 7. Yeah. So these two numbers are removed. 9 will be still there. So for 9 we haven't find any answer.
Yeah, true.
4 it will be 7, and for 2 also it will be 7.
Yes.
And now we have 7 also in the stack. So what is the index? 4, 5, 6, 7.
But we don't need to go, right? When we reach the end, then we can stop, or we have to do it. We cannot stop. We have to do it till the end, right? Because we might find. Okay.
Yeah. So this was index 4, 5, 6, 7. So 7 will also be inserted. 7.
Yes.
And now we'll go to next number. At index 8. Number is 6. So it is again like less than stack dot top. So we will move ahead. Now we have index 9.
Yes.
Yeah. So index 9. This index 9, the number is 9. It is greater than this 7 and 6. So we can remove those two numbers and set the answer for them as 9.
9. Yes.
So this will be removed, and this will be removed, and this will be 9, and this will again be 9.
9. And we just return the first n element of this array.
Yes. Yeah, we will return the first 10.
Yeah, seems right. So you can share the screen. One second. I will. Okay, you can share the screen, and we can try to implement this now.
Yes, I'll share my screen. Yes, so yeah, is it visible?
Yes, not yet, but yeah. Now it's visible. Yes.
Yeah. Yes, so is it visible?
Yes, you can see it.
Okay. Yeah, so the first process is same. We have to like double our array. 1 to 1 will become 1 to 1, 1 to 1.
Yes.
So what we can do is I equal to 0, I less than n, I plus plus. I'll go to the n minus 1 index and push that same number again.
Okay.
Yeah, nums dot push back nums of I.
This.
Now we will have vector of int answer, and can we just stop this process after the nth, like if after the n minus 1th index?
No, because we might
we
get
have
updated.
answer.
Yeah, we have to complete the end and then return the first n element. Yes.
Okay. Yeah. So this will be 2 star n. And do we have some limit on numbers, like here? Like, will all these numbers be positive?
No, it can. No, yeah,
No.
I think it doesn't matter. Even it's negative, it should give you the solution. But I think it's still positive, because if it's negative, then it will be create confusion. -1.
Yeah, because
Yeah.
like we cannot store like -1 in all.
Yes. So should be positive. I think yes.
Yeah. So stack of int st for int I equal to 0, or I think we can directly push the first number. So stack dot push nums of 0. Then for int I equal to 1, I less than 2 star n, I plus plus. Yeah. So let me take that example. So if st dot empty stack.empty, so we will just. Or
I think you
we
made a
can check
typo
some
in
other
line 18,
condition.
right? It should be dot. Yeah.
Yeah. Or I think we can. So while not stack.empty and stack dot nums of stack dot top is less than nums of I.
Mm-hmm.
So we will take the index which is at the top of stack. So it is st dot top, and we will remove this index. And the answer for this index is equal to nums of I.
Yes. Right.
Okay. Yeah. And after the while loop, we can just push the current index, that is I. I think this will be enough.
Like let's do a dry run and see if it works. Like let's take the first example and for index I, yeah, just do a dry run and see if it works.
So at the beginning we have in the stack we have 0, then I equal to 1. So while not stack.empty and then nums of stack.top is less than nums of I. Yeah, so this 2 will also be inserted. So index 1. Then when this 7 comes, the answer will be, we will have answer for 4 and 2.
Yes.
Yes. And then this will be inserted. So 0, 1 will be replaced with 2. Then 7, then 6, then 6 will come. Yeah, I think it will work.
Yes. And just return the first n elements.
Yeah, so return vector of int. I think I can create one more vector, but I'll use a constructor. Answer dot begin and answer dot begin plus ends.
Yes.
Yeah. Okay.
Yes.
Yeah, I think we can check with our example.
It's working already. Yes. We can.
7, 6, 9.
Yes. Yeah, seems to be working fine. And
yes, we also got this. Yes.
Let's submit it.
Yeah, passed.
Cool.
It's I also tried with my method. Like it also works. Like I just have to make a modulus of n in some cases. Like everything else is the same logic.
Okay, fine. You can also try it, and if it works, then you can also write it in the tutorials.
Actually,
yes.
It
Okay, so what time is it now? Yes, I think we can solve one more question. Okay, Chitresh, you can open the problems and let's see.
Yes. Yeah, so which problem to attempt?
Let's see. Let's do the remove comments 722.
Okay.
Is it too big, right? Is it too big to read this question?
Yes, I think.
It has a lot of dislikes too.
Okay, then just go back and solve other question. Okay, maybe I can select the top questions because I have the premium membership,
Okay.
so I can select
Okay,
a
so
popular question. Or let's take some Amazon or like Facebook and solve it.
I think I have access to this top interviews question.
Okay.
Yes. Okay, I think we have only 4.
Okay.
No, you can
Let's try.
go to the first page.
Okay.
Yes.
Yeah.
Let's try this question. The generate parenthesis.
Okay. Yeah. Yeah. So, given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses.
It just
Yes,
screams to
so-
me that it's like a backtracking question.
Yeah, and like constraints are
Yes,
also
yes.
so.
Yeah. Fine. So we can discuss it in the Google Sheet and then we can implement it using backtracking.
Yeah. Yeah. Okay.
We can create like a pattern, like which questions you can solve using backtracking and which questions you can solve using BFS. You can create like a tutorial where you can create pattern and which questions you can solve using this pattern. So we'll do it some other time.
Yeah.
So let's open the Google Sheet doc and let's try to do a backtracking and solve it.
Yes. Okay. Okay. So.
Saurabh, you
So
want to
we are
implement it?
given-
Like, just give me a second.
Okay.
Let's do it in Java.
So, like, should I directly write the code or?
Yeah, like
You will try
you can discuss it here, and then we can just discuss the code here, and then you will use the Java editor to just at first discuss it, then we'll see what to do. So yeah, discuss it.
Okay. So here we are given n equal to 3, and these are the possible parentheses that we should generate.
Mm-hmm.
And this they should be like proper, like every like the brackets should be closed.
Yes.
Okay. So what I can do.
Let's also put the example here.
Yeah, like let's just take a list where I will store all my list of strings, and make a utility function where I will make all my calculations.
Mm-hmm.
And its input is an empty string. Okay. So what I can do, like we have to generate balanced strings, balanced parentheses, right?
Mm-hmm.
So I can take one counter, like for one is for the left parenthesis, like the number of left parenthesis we need to generate, and one is right.
Mm-hmm.
So this should be the number of right parentheses which we need to generate.
Mm-hmm.
So this is my util function, and for this function, like okay, if the function like string, this is my str, and int left, int right. So I will do all my work in this method, And
Maybe you can share the screen because we cannot see it. So do one thing. You start sharing the
okay.
screen, and then you can solve it in your uh, editor.
Okay. Visible?
Yeah.
Okay.
Yes.
So I will just okay. Let's utility method. This is the utility method, which will take one string as an input, and there are two integers, like right and left. Okay, so
I mean, the left can go till n, but the right cannot go more than left, right? That is the logic.
if the left is not 0, so we can add another string to it and make a call to this method. No. Okay, yes, now I get it. Okay, so I will a temporary string here, which will be equal to this. I will do the dry run later.
Don't start writing the question like answer. Just first discuss it in the Google Doc. We understand how it works. Then we can write the code.
Yes. So at first, for the example, I have one empty string, the total number of left braces and the total number of right braces. Okay. So this is my parameters for this method. So what I can do, like this left, this is so
I mean, we have to create a string of length 2 into n, right? Like n is the number of
yes.
And for every step, we can do two things. We can either use left or right. But the thing is, the right can, if the right is equal to the left, then we cannot use right again. Because in every step, the right has to be equal to or less than the left parenthesis. Something like that, right?
Yes.
So what I'm thinking, like if we put one left brace in here, we will put it.
Yes.
Right.
You can always put the left brace. Still, the left is not.
Yes.
Yeah.
Okay. So at first, we are having this, and as the value of left is not 0, we can put one left brace here and increment the left counter. Okay. So is it clear? And for the next iteration, like we will make a recursion here. We can also check if it is so the value of 2 is not 0, so we can also put one left brace here, and we can do it like this.
And also you can do
that.
Yes.
We can do this also. Okay.
Yes.
So then as the left is equals to 0, now we have to go to our next step where we have this as a string, and as the value of right is greater than left, so as 3 is greater than 0, we will put 1 this.
Yes.
And value will be this.
2. Yes.
After that, we can also do this. And
But I think there is one, like, for the which one you think is more understandable? If you take 0 0 in the beginning, and when you reach 3 3 at the end, you stop it. I think that will be more understandable. Like, what I mean is, like, 1 second. So what I mean is, like, first we will start with empty, and we have 0 left, 0 right. So we have two possibilities. We have this. No, we have only one possibilities, because we cannot.
One possibility.
Yeah, we cannot use this. But for the second case, we have two possibilities. Like, for this case,
Yes.
we have two possibilities. We have, like, this, and 2
Or
0, or we have
mm,
this 1 and 1. Like, and then we have, for this case, we have again two recursion, which will be this
Yes.
and 3 and 0.
Mm.
Or we will have one more possibility, will be this and this, which will be
this
2 and
One.
1. And when you reach 3 3, we save it in a global array.
yes.
Does it make sense?
Yes.
Okay, so
Yes.
let's implement it like this way. This is more understandable.
Like, should I implement it, sir?
Yeah, just write the code.
Okay. Like, there is one list of string. This is our answer,
Mm-hmm.
and answer is equal to, let's say, we have this method as solve. And it's our 0.
Also pass the n, because you need to know when
Oh, yes.
you are reaching
Yes.
the end. And let's define the best case first. Yes, yeah.
If a string dot length is equal to 2 into n,
Yes.
yeah, this is 6. So I will add this string here.
Okay, yeah, true. Makes sense.
So if left is not equal to n,
It's less than n.
is okay, is less than n, then we can do like string dot suppose that 1 string n this,
Yes.
right, and we can call
Solve
this
temp 1.
method left should be incremented by 1, right should be as it is, and n should be as it is. And here, if right is greater than left, right, because we have to also make those strings valid.
Yeah.
Okay.
Now, if right is less than left, then you just add it, or you just don't do anything. That will be right. If right is less than left, so you can add a right. If right is less than left, then you can do it, right? Then you can add a right. Yes.
Oh, yes. I have this. Okay, so one, this.
Chitresh, you have any comments?
No, I think we are going correct.
Okay.
String dot length. Okay.
Cool.
Yeah, this should work.
Yes.
Yeah.
Great. Cool. So let's stop it here, and